In this video, I'm going to explain how to solve what's called oblique triangles. Oblique triangles are triangles that are not right triangles. So we have all kinds of methods to solve right triangles, but in these next two videos I'm going to show you how to solve a triangle that is not a right triangle. They're called oblique triangles. One method is to use the law of sines, and it's going to be an equation that you can either look up or you'll be given. And then in the next video I'll show you a different one. It's called the law of cosines. So let's get into the law of sines. If you see an oblique triangle, in general you can set it up like so. Label the vertices or angles with capital letters. And you're going to label the side that is across from the opposite side from the angle with a lowercase letter. So the side that's across from angle A gets a lowercase letter, and that's going to identify the length of the side. So across from angle B you got side B, and across from angle C you have side C. And if you can set your triangle up like that, you can use the law of sines. The law of sines is this: either the sine of your angle over the side length, and now we're going to set up a proportion that's equal to the sine of one of the other angles over its side length, and it's not necessary, but this would be the law of sines. And now it's not necessary to set up all three ratios. In fact, you probably don't want to do that. You're going to want to pick two of these ratios, either these first two if you have enough information there, or the last two if you have enough information there, or the first and last one. You don't need all three ratios. You only need two ratios. You only need one proportion. So if you can set up a proportion, you can solve it by cross multiplying and solve for at least one missing variable, either a missing angle or a missing side. But in order to do that, you're going to need at least 3 out of these 4 values in your proportion. Alright, let's do some examples here. So in this example, we're going to be given a side value. We'll know that side B is 26. We'll know that angle C is 103 degrees. And we'll be told that angle B is 28 degrees. So this is called a special case here. It's an angle side case. We got angle side as we go around the triangle. If you ever see a triangle with that given information, you can use law of sines. So we're going to set up what we know. We definitely know the ratio of B. So we know the angle B and we know side B. So I'm going to set that up. Sine of my angle over the side length. Now I forgot to mention this, it's not a huge deal. If you set up all of your ratios with your angles on the bottom and your side lengths on top, it will still be solvable and you can still solve it that way. But you have to set up every single one of your ratios the exact same. So either you could put sine of angles on top in your equations, or you can put sine of angles on the bottom. As long as you do that to every ratio, you can still solve it and it works out. Alright, so now I need to set up a ratio where I know at least one of them. So if I look at my C's, I know at least the angle, and I can solve for the side. So sine of 103 over C, that's our unknown. So because I know 3 out of my 4 values in my proportion, I can solve this proportion by cross multiplying. So on your calculator you're going to want to find the sine of 28 degrees. Make sure you're in degree mode and not radian mode, and just cross multiply. So if we do that, I'm just going to set it up. I'll let you use your calculator. So if you find the sine of 103 degrees, multiply that decimal value by 26, and then divide both sides by the decimal value of sine of 28 degrees, then you will solve for c. This will go away. When you do this division, you will get the length of c, and I believe it's about 54. And then you can always check and see if it makes sense. This is a fairly large angle, 103 degrees, so I should have a side that is definitely larger than B. Longer sides are across from bigger angles, smaller sides are across from smaller angles. So if I just kind of check my work, it seems to make sense, and I can be more confident. Alright, so there's C. In order to solve for A, I need to know at least the side measurement, or I need to know the angle measurement. And so we can take a little shortcut to do that. Anytime you know at least two angles in a triangle, you can find that third by simply subtracting. We know that triangles add up to 180 degrees. So if you add up the two angles you know and subtract that from 180, that will give you the measurement of that third angle. So we'll do that real quick. 103 plus 28. This is essentially what we're doing. Add up what we know and subtract it from 180. So that's 131. So we must be missing 49 degrees. So if we fill that in, now we can solve for side A. And in general, you're going to want to use values that were given initially, just because it improves your accuracy. Because I rounded this value slightly, if I again use it, I'm going to get farther away from being accurate for side A. So I'm going to go back and I'm going to start with B, because those values were given to me initially. And now I can set up my ratio for A. So we say sine of the angle over the side value. We cross multiply and solve. So if we do sine of 49, find that decimal value, multiply it by 26, that should equal sine of 28 degrees times A. So to solve for A, we divide by the sine of 28. So this will go away and allow us to solve for A. If you find the decimal value of sine of 49 times 26 and divide that value by the sine of 28 decimal value, you get the value of A. And so on my calculator, it tells me that it's about 41.8. Alright, so we just solved the oblique triangle. Solving a triangle means finding all the missing values. We solved for the missing angle, and we solved for the two missing sides. And that was an angle-angle side case, and we used the law of sines to do it. We'll look at one more case here. Another oblique triangle. Angles labeled with capital letters. Sides that are across from those angles are given lowercase letters. We're going to be given A, and we're going to be given side C, and we're going to be given angle A. So again, because we're given a ratio, an angle compared to its opposite side length, that's a good clue to tell you that you might want to use law of sines to solve this. But this triangle, slightly different than the last one. This one, as we go around, is angle side side, or side side angle, either way. We don't normally say angle side side. So in this case, we can still use law of sines. And again, because we are given a ratio of a side length and its opposite angle, then we can generally use law of sines. So we're going to find the angle that is across from the side value that we know. So I'm going to use a ratio of A, and I'm going to set it equal to a ratio for C. So I'm going to show you that it can work out either way here. If I put the side lengths on top and the angles on the bottom, it should still work. So this time we're going to be solving for an angle. So again, we cross multiply to solve a proportion. Sine of 61, whatever that decimal value is, we're going to multiply it by 35. And we're going to set it equal to 55 times sine c. So if I divide by 55 first, then that will give me, let's see here, if you take this and use your calculator, it should give you a decimal that's pretty close to this. So I found the decimal value of sine of 61, I multiplied by 35, and then I divided by 55, and I get this decimal right here. And so that decimal value is equal to whatever the sine of my angle C is. In order to solve for an angle, you're going to want to use an inverse function. So now the last step is just to find the inverse sine of this decimal, and it will give me an angle measurement. And the angle measurement that it gives me is approximately 33-ish, 33.8, somewhere around there. Okay. Now that I know two angles in a triangle, I can set it up and solve for that third angle by taking what I know and subtracting it from 180. So if I add up 61 and 33.8 and subtract that from 180, I should get about 85.2 degrees. So we're almost done solving this triangle. Last thing we need to do is solve for angle B, or sorry, side length B. So we'll set up one row ratio here. Again, we're going to start with the ratio that we were given at first because it improves our accuracy. So if I set up the ratio of A again, and set it now equal to the ratio of B, sine of the angle there. Cross multiply and solve again. So whatever this decimal value is times 55, that should be equal to sine of 61 times B. So we're going to divide both sides by the sine of 61 to solve for B. This goes away. So if I find the decimal value of sine of 85.2 and I multiply by 55 and I divide that value by the sine of 61 degrees, I get my side length for B. And it's approximately 62.7-ish. And so we have now solved this oblique triangle. So again, you can flip your law of sines and put the angles on the bottom and side lengths on top, and it will still be able to give you a correct answer. So that's up to you, however you prefer to do it. And so in general, to use the law of sines, remember, you always got to have at least one of these ratios. You got to know a side length and its opposite angle value, and at least one other value, either a side length or an angle that's across from that. If you know 3 out of those 4, you can set up a proportion and use the law of sines to help you solve those oblique triangles. So good luck using law of sines to solve oblique triangles. In the next video, I'll show you a new method called law of cosines, and we're going to use it to solve a slightly different problem.